So as we get into section 6.4, we're going to take kind of a quick step back and look at where we've come from and then take a look at where we're going to go to. We started out this chapter with factoring, in particular factoring out the greatest common factor. So let's do that for this one, which is taken out of section 6.1. There's actually two things we're going to do, and I'll do them in two steps. You can do them in one, that's fine. One thing that a problem like this would ask you to do is factor out the negative. So do you remember what we did when we factored out a negative? There was kind of a shortcut that we took. Just change the signs. So it's going to be 24x to the fourth plus 48x cubed minus 36x squared. All right, so we factored out the negative, yay. More importantly, and the bigger amount of work, is to also factor out the GCF. So I'll take that, leave that negative out front. What's in common to all of the number parts? What number goes into all those? 12. Very good. So 12 goes in there. And how many x's do they all share? 12x squared. Now, technically, this divides each of those terms. So 12 goes into 24 twice. We're taking out two of the x's. That leaves behind an x squared. How many times does 12 go into 48? 4. Plus 4. How many x's are left? And then here, just a 3. Now, is there a greatest common factor in the parentheses? No, there shouldn't be. If you accidentally looked at this and said, oh, well, gee, I'll take out a 4, then you'd find a greatest common factor. You'd have to factor that out still. All right, so that's factoring out the GCF. That's one thing that you can expect. There was some more work that we did in section 6.1, and that was to factor by grouping. Now, factor by grouping is when you had 4 terms here. So this is an example of a factor by grouping problem. In fact, it's a good example because you can't just charge ahead and do the factor by grouping right away. You've got to reorder this. Now, there's 24 different ways you can do this. Let's just try putting it in descending order. Y to the third minus 4y squared plus 3y minus 12. And let's see what that does for us. Well, hopefully a lot. Let's take a look at the first first pair. Is there something in common to those two that I can factor out? A y squared. So y squared, that's going to leave behind y minus 4. And then from the second pair, 3 times y minus 4. And then y minus 4 times y squared plus 3. And what we did there at the end was notice that this was a common factor, factored it out, it left behind the y squared plus 3. So, yay. So that was the essence of section 6.1. In section 6.2, we started factoring things that had 3 terms. So, assuming that you've already looked for a greatest common factor and there isn't one, the trick on these was to try and find 2 numbers that multiply to this and add to this. So we'll write it as the product of 2 binomials. We'll start out with an A and an A. Because that last sign is negative, what do I know about these 2 signs? One has to be negative and one has to be positive. They have to be opposite in sign because a negative times a positive will give you negative. If these 2 signs were the same, then you'd have a positive here. This is probably not an example that I would use on a test. Most people aren't really comfortable or familiar with the number 39. But number 39 is actually divisible by 3 and 10, or excuse me, 3 and 13. Which one of these should be the negative? Which one should be the positive? Yeah, the larger of these is going to have this sign. So minus 13 and plus 3. Okay. Finally, we worked on a different set of polynomials. So that was section 6.2. In section 6.3, we had the not so nice case of factoring polynomials. And the not so nice case about the not so nice case is that you had a coefficient in front of your x squared term that was different than 1. So in this case, there was a 1 in front of the a squared. Here, there's not. There's a 15. And that meant a lot more work here for us. So what was that work? Well, that work was you start out by multiplying the outside numbers. So let me give myself some room up here. 15a squared minus 28a plus 5. Outside numbers, 5 times 15 is 75. That's our first step. Second step is find two numbers that multiply to this and add to this. So find two numbers that multiply to 75 and add to negative 28. So let's understand where those numbers are coming from. The negative 28 comes from that middle number, and the positive 75 comes from this number. Now whatever those numbers are, both have to be negative. So a negative times a negative will be a positive, but a negative plus a negative will still be negative. Those two numbers, to kind of move this along a little bit, would be negative 3 and negative 25. Those are the two numbers that I needed. If you get those two numbers, then the rest shouldn't be too bad. I can split up this middle term using those two numbers. So let me do it this way. We'll split this up as 15a squared a minus 25a plus 5. Now we're back to what we did in section 6.1, the factor by grouping stuff. So what should I factor out of the first pair? I'd just go with a positive 3a. So 3a times 5a minus 1. And from the second pair, I'd factor out a negative 5, actually. Because if you factor out a positive 5, then the terms inside the parentheses won't match these terms. So negative 5 times 5a minus 1. Notice that factoring out the negative here changed the sign on both of those terms. Overall, 5a minus 1 times 3a minus 5. So there you go. Finish factoring that one. So that's kind of a quick review of stuff that we did in 6.1, 6.2, and 6.3. Let's move on to section 6.4. In section 6.4, we're going to work on a couple things. We're going to do some stuff like this, section 6.4, and a little bit more with some difference of squares and sum of squares. So that'll be up here in these two, 6.4 and 6.4. Okay, let's start out with this kind of stuff. And really, I'm not going to treat it much different than I would any of, well, let's see, maybe we should. But initially, it's going to start out just like factoring trinomials in the nice case. Let's start with problem number 28. You know what? Hang on a second. I'm off a little bit on that one. 22. There we go. So this is section 6.4. There we go. Problem 22. X squared plus 10x plus 25. Well, this is a nice case of a trinomial. So let's work on factoring this. Micah. What numbers or what terms can I put at the beginning of each of these parentheses? All right, x and x. Good. How about the signs in this one? Nick? What signs do I have to have? Plus or minus? Both have to be plus. And Ted, I need two numbers that multiply to 25 and add to 10. Good, 5 and 5. Now I do have a request here for you. And it's a little bit more than a request. I say request, but I'm just being polite. I would like you to rewrite this. How could I rewrite this? X plus 5 squared. There will be 1 point of credit given on an exam for writing it like this. You write it like this, you get 3 points out of 4. Write it like this, you get 4 points out of 4. So make sure you write it like this. One thing I want to point out, in fact, some of my calculus students would do well to pay attention to this. When you square this out, you don't just get x squared plus 25, do you? You can't just square each of these. If you FOILed it all out, you'd get that middle term here. So in squaring these things out, you can't just take a shortcut there. Let's try a similar one, problem number 24. M squared plus 12m plus 36. Okay, so what are we going to start with? Mark? M and M, good. All right. Megan, what signs? Plus and plus. And Victoria? 6 and 6. Good. But Jackie, we're not going to end up with this like this. What should I write? Good, m plus 6 squared. So we're seeing this again, that we've got this pattern where we end up with a squared binomial like this. That makes this, Ted, this makes this a perfect square trinomial. So when are we going to see such things happening? Well, there is a little bit of a pattern here. And that is, if something falls into the pattern of a squared plus 2ab plus b squared, then it's going to factor into a plus b quantity squared. That's a pattern that I'd like you to recognize. So this is going to factor into something like this. So what are the clues that you should be looking for? Well, the n terms have to be perfect squares. So I had an m here and a 6 squared here. Okay. The middle term is twice the product of those n terms. So let's see if we can't reverse engineer one. Problem 28. Problem 28 is 121 plus 4x squared plus 44x. Okay. Before I get going on this one, let's reorder this one. What's the different order that I could write this in? Good. 4x squared plus 44x plus 121. Now, what could catch our eye here is that this n term is a perfect square. What would I square to get this term? 2x. All right. How about this term here? 11. Now, if the n terms are squared, Let's check to see if the middle term fits the pattern. Is it 2 times A times B? Well, 2 times 2x times 11 would be 44x. So it fits. It fits that pattern. That's nice because that tells me that I can rewrite this then as 2x plus 11 quantity squared. It's nice if you see this pattern. It's nice if you can rework them like this. You don't have to. You could factor this like we did the first couple as this times this and say, oh, well, I got that squared. It would work out the same way with problem 28 and stuff like it. Let me do one more for you like this. I'm not going to put too much emphasis on this. It's great if you can see it. If not, it's not life-threatening. Let's take a look at problem number 34. 3v squared minus 42v plus 147. Now, none of these look like perfect squares, especially on the end terms. 47 is not a perfect square. 3 is not a perfect square. You've got a list of perfect squares on the left-hand side board. So, well, think about your factoring strategy, that worksheet that I gave you. These are kind of different steps to think about. Does anything strike you in terms of something we can do with respect to problem 34? Well, you don't have to look very far down the list. Greatest common factor, always. So what's the GCF in something like this? A 3. There's a 3 that's a factor of all of these terms. So factor out the 3 and then see what you can do with what's left. I'm going to walk around and see about helping you out. After you factor out the 3, keep factoring it. It should factor nicely. Don't lose the 3 from your factorization. It should be part of your final answer. You should be able to factor that trinomial that you get there. Okay, so factoring out the 3 leaves behind v squared minus 14v plus 49. Now, if you can recognize that, gee, the n terms are perfect squares, there's a v here and a 7 here, both of which get squared to give us the n terms, you can check that it follows a pattern much like this. The only difference is we've got a negative there. So now, there's nothing wrong, though, if you're not comfortable with those patterns. If you can't look at that and say, gee, that's v minus 7 squared, then just treat this as a regular polynomial. Regular trinomial in the nice case. So I need a v and a v. What are two numbers that multiply to 49 and add to negative 14? Negative 7 and negative 7. And that's great, but I asked you to go one step further with these. Leave the 3 out in front, v minus 7 squared. Okay, that's about it for the special cases down at the bottom of our handout here. That's these right here. So you can get, this is your a plus b squared, this is your a minus b squared. If you can catch these, great. If not, at the very least, write them as binomials that are squared. These are so-called perfect square trinomials. But there is another little case that we're going to work on from this section, and it's called the difference of squares. So, unless there's some more comments or thoughts on that one, let's move on to the difference of squares. A squared minus b squared. So-called difference of squares. Because you're subtracting two squared quantities. So the difference of squares actually factors pretty nicely. It's going to be a minus b times a plus b. Of all the different factorizations that we're going to encounter, this one arguably is one of the more important ones. Now, at the same time that there's a difference of squares formula, there's also this formula, a squared plus b squared. I think you kind of like this one. But let's prove this one first. Let's show that it actually works. How can I check that this times this gives me this? Yeah, multiply it all out. So if we check it, I would get a squared plus ab minus ab. Last terms would be minus b squared. And something nice happens with the terms in between. They cancel each other out. So you're left with a squared minus b squared. So it checks. A squared plus b squared is a different matter. A squared plus b squared, well, you could try a bunch of different factorizations. You could try a plus b times a plus b. I wouldn't copy this down. A plus b times a plus b would be a squared plus ab effectively twice. Now, do these terms in the middle cancel each other out? So it's a squared plus 2ab plus b squared. So that doesn't work. If you tried a minus b times a minus b, you'd end up with something similar except a minus sign in between here. So that doesn't work. And then you say, oh, well, I'll mix them up. I'll do one of each. But that gives you a squared minus b squared. In fact, has anything worked here? No. So this is prime. Now, it's a subtle difference between these two cases. One's prime, one factors. But it makes all the difference in the world. With real numbers, you cannot factor that. So let's practice a few. We'll start with problem number 42. It's our difference of squares. Difference of squares. A squared minus b squared. So 49 minus w squared. One thing that should catch your eye, and it's really part of your factoring strategy, the way I've laid it out, and that is you're factoring something that has two terms. And that's key, because if you're factoring something that has only two terms, there's a limited number of things that you could do. It could be the difference of squares, or the sum of squares, sum of cubes, or the difference of cubes. We haven't done this yet. That's section 6.5. But there's a limited number of things you can try. You can't do factoring by grouping because there's only two terms. You can't factor it as a trinomial. There's only two terms. So it narrows down the list of things you want to try. So you start thinking about the difference of squares. What do I square to get this? What do I square to get this? W. So 7 minus w. What's the second one going to be? Thank you. 7 plus w. Yeah. And that's it. Sabrina, how would I check that if I wanted to? Mm-hmm. Good. Perfect. So it checks. Thank you. This is our answer, though. Let's keep that there. Nice. Thanks, Sabrina. Let's try a different one. Actually, a couple more. Problem number 44 and 48. 44 is h squared minus 144. And you know what? We'll skip 48. Let me give you my own example. 81 minus b squared. Karanja, how about problem 44? How's that going to factor, please? Mm-hmm. Good. Now, what if Tomer did h minus 12 times h plus 12? Is that wrong? No. The order of the signs doesn't matter. As long as you have one positive and one negative, the order at which you put those doesn't matter. So, all right. Thank you, sir. Yeah, question? No. No. If you have two terms like this, then they both have to have opposite signs. Yeah. Yep. Okay. How about the next one then? What's the next one going to look like?
Let's do 9 minus b and 9 plus b.
Perfect. So again, the difference of squares. Now, the one that I kind of backed off on was this one. It's problem number 48, x squared minus 27. 27 isn't a perfect square, is it? So the books list this as prime. I wouldn't give you one like that. I mean, personally, there are things that I would like to do with that one, but I wouldn't give you one like that. Not on an exam.
So there's no solution.
There's nothing that we're going to work with. The book calls it prime. I'm going to leave it at that. And the reason for that is because this isn't a perfect square. If this was a 25 or a 36, we'd be in business. If it was one of the numbers on that left-hand side board, Okay. Let's take a look at problem number 46 then. 121 a squared plus b squared. Stop. You're working too hard. Yes, sir. Nope. Ah, going back here. Yeah, somebody got it. Who got it? Somebody said it. The prime word. Yeah, well done. Because this is a sum here, the sum of squares is prime. So that's it. You got a sum here. Sum of squares is prime.
That was easy.
Yeah. That's all you have to write. Prime. What's that? Only when it's negative can you factor those things. Jackie, question? You got it? Okay. All right. You're just thinking, wait a minute. That's it? It's too easy. All right. Now, we're going to build on this a little bit. There's going to be other things you're going to do in terms of working with the difference of squares. The first thing is this. What do I mean by GCF? Somebody said it. Greatest common factor. Thank you. Thanks, gentlemen. So, GCF. Even though we're working with the difference of squares, look, it's the very, very top of your handout here. Always factor out the GCF. Period. Well, this coming Monday, I'm going to have a little chance for extra credit, but you're going to have to know your factorizations. Practice them hard over the weekend. You'll have a chance to earn some extra credit this Monday. And I'll give you your choice of how we do it. But let's take a look at problem number 58. Basically, I'm going to be quizzing you on your factorizations. 2a squared minus 200b squared. There's only two terms, and if you look at that thinking, well, gee, wait a minute, he said two terms. If there's two terms, that should be one of these things. And, well, that's not a perfect square. Neither is that. Did I lie to you? No. All right. Let's give these ladies up here a rest. Somebody else pick up the slack. What should I do next? Now, you guys are really good about volunteering. Ruben, thank you. Yeah. Factor out the GCF here, right? That's this part right here. Factor out a 2 Casanilla. What would that leave behind? Perfect. A squared minus 100b squared. That 2 divides both of those terms. We can continue factoring this now, right? You should recognize the difference of squares here. A minus 10b. Good. And A plus 10b. Yay. And that's it. If you wanted to check yourself, what I would do is I'd FOIL those two together first, clean it up, and then distribute the 2. That's correct. What we've got there is correct. Problem number 60. 20x squared minus 5. GCF first, George. What would be the GCF there, please? Excellent. This one's a little tricky, but this one continues to factor as the difference of squares. So, big E. Let's figure out what we square to get these. What do we square to get the 4? And then the x squared? So 2x minus, and then big E, what's the rest of it? Thank you. Cool. 2x minus 1, 2x plus 1. The 5 has to stay out in front. If you lost that 5, you're going to lose a point. The 5 is your GCF, has to stay with you. Okay, so factor out GCF. That's one thing you look out for with these things. In fact, always, always, always factor out the GCF. Period. I think I warned you about this, or maybe I'm confusing with another class today. When I give you these kinds of headings, I'm really telling you, it's like, okay, expect at least a problem like this. That's exactly what I'm telling you. So, kind of writing the test before your very eyes. Let's look at problem number 62. Y to the fourth minus 625. So, is there a greatest common factor here? No. Okay. But you've got two terms, so you start looking at that going, well, wait a minute. Come on, Jeff. 625, that's bigger than what we've got on the right side or on the left-hand side board. So, okay. But we're not technologically ignorant. How can we figure out what to square to get 625? What do you square to get 625? Take your square root, right? Square root of 625 is 25. Right? So, okay. That helps us out a little bit. Now, I know I'm going to need a minus 25 and a plus 25. The question is, what do you square to get y to the fourth?
Y to the power of 2.
Perfect. Y to the second power. Great. So on a test, you've gotten 2 points out of 4 by giving me this answer. Well, why? What's wrong with that? What's wrong with that is that we're not done. What else can we do? Mara? See anything else we can do?
You want to factor
Maybe.
it one more time?
Yeah, let's factor it one more time. Can we factor this a little bit more?
So,
What would it be? Good. Actually, just y plus 5 and y minus 5. How about this term? Why do I keep this the way it is? How come I don't factor that as y plus 5, y minus 5? Ah, right. What about this? Remember, it's the sum of squares, and the sum of squares is prime. So we can factor the first one again, but not the second one. So, I just called it a double factor, but it's something that I want you to look out for. I'm telling you, I'm promising you it'll be there. Let's try another one like that. Problem number 64. M to the fourth, n to the fourth, minus 16. It's going to be very similar to the one we just did. So look for that double factorization. Andrew, start us out, please. What's the first step going to look like? Good. So m squared n squared minus 4, m squared n squared plus 4. Cool. But we can keep going, right? The second one, or the first one here, is again the difference of squares. So this one stays the same, but this one's going to continue to factors. mn minus 2 and mn plus 2. This one stays the same. Yay. Okay. How are we looking on that one? So those are a couple double factorization ones. Let's do one last one, and then maybe kind of a couple review problems. 2p to the fourth minus 32q to the fourth. So kind of adding to the mix a little bit. Jenna, suggestions on where to start here? Factor out a 2. Good. That's going to leave behind p to the fourth minus 16q to the fourth. Good. Sam?
P squared
Mm-hmm.
minus 4q to the 2.
Good. Minus 4q squared, and then a plus 4q squared. Okay. Almost done. What's the last step here? What else do I have to take care of? Yeah, factor the first one. It's going to be p minus 2q and p plus 2q. This one stays the same, but we still have to write it. So make sure you don't forget it out of your final total. Yeah. All right. 2 last ones. Problem number 76. 25 plus b squared. Quick answer on that one. Somebody. Yes.
That was easy.
Prime, yes. And problem number 90. Negative 81 r squared minus 18r minus 1. Suggestions on this one. What would I do to start this one? What would you do to start? Factor how? GCF. What could I factor out of all these then? Yeah, let's factor out that negative. Thank you much. So 18r squared plus 18r plus 1. And this actually follows that special products formula that I mentioned. This is a perfect square. What do I square to get 81r squared? 9r. And that's a 1 squared. 2 times this is going to give me that middle term. So this is really 9r plus 1 quantity squared. If you can get those, it's great. You can factor this the long way. That is the way we did in section 6.3. Multiply 81 times 1. Find two numbers that multiply to 81 and add to 18, etc. It'll eventually work. It'll eventually get down to here. It's just a nice shortcut if you see it this way. Okay, for homework. Try 13 through 29. 31 through 53. 61 through 87. Now, the last few here, 97 through 107 our review. So yeah, not as important as some of these other ones if you get in a pinch for time. But when you get ready for the exam, maybe there's something to look at.